So book one, prop 34 says in parallelogrammic areas, the opposite sides and angles are equal and the diameter bisects the area. So we'll start off by drawing up our parallelogram or our parallelogrammic area. And we'll call it ABCD. And we're going to connect D to B, and that will be our diameter. And I'm going to write up our to proves here. So to prove, we want to show that angle A is going to be equal to angle C, that the whole of angle D, all of angle D is going to equal the whole of angle B, that the side AB is equal to the side DC, that the side AD is equal to the side BC, and then we're going to prove that basically that the triangle ADB is equal to the triangle CDB, which means that the whole parallelogrammic area would be cut into two equal sections, so it would be bisected by the diameter BD. So I'm going to say here that triangle ADB equals triangle CDB. Okay, so Euclid starts by saying, since we know that this is a parallelogrammic figure, we know that AB is parallel to DC, and those parallel lines have been cut by a transversal. So according to prop 29, which starts with parallel lines, we know that, actually I'll do this in a different color, we know that the angle ABD is equal to the angle BDC. So I'm going to put that as step one right here. And maybe I'll number these just for the sake of brevity. We know that angle 1 is equal to angle 2, and that's book 1, proposition 29. Step 2, we apply the same proposition, and we show that, I'll do these in green, that angle 3 is equal to angle 4. So maybe I'll write that in green here. So angle 3 equals angle 4, and that is also prop 29. And now we apply proposition 26. We're going to apply the side angle part of that proposition. So we know that angle 2 is equal to angle 1, and angle 3 is equal to angle 4, and DB is a side that adjoins all of the equal angles. So now we can say, I'm just going to write it under step 3 because it all follows out from proposition 26. We can say that this whole angle here, which remains in these two triangles, is equal to this whole angle here, angle C. So angle A equals angle C, which was our to prove up there. And also we know that the remaining sides respectively are equal in each of these two triangles, so that side AD equals side BC, which was this to prove right here. And we know that AB will equal DC. Equals DC, which was this to prove right here. And now if we look at these two angles, the whole angle at D and the whole angle at B, we can see that their parts, which are 2 each, are respectively equal. Therefore, the whole angles are equal to each other. So that would mean that the whole angle D is equal to the whole angle at B. Just step forward here, I think Euclid cites common notion 2 on that one. So equals added to equals makes equals. So we can say from common notion 2 that the whole angle D equals the whole angle B, which was this to prove right here. And then the final part is to show that this triangle ADB is equal to this triangle CDB. And he reverts back to prop 4 for that one. So we can say via prop, well, maybe I'll say this first. We know that AB is equal to DC. We know that angle 1 is equal to angle 2, and we know that BD is common to both triangles. So we've got side, angle, side, side, angle, side. So we can say via prop 4 that the triangle ADB, the triangle ADB is equal to the triangle CDB, which means that we have bisected the parallelogrammic area with the diameter BD, which rounds out our to prove, so QED.